presentations. This will be the last set for spring. So thanks everyone for taking time to show up today. We've got a pretty full docket of presenters, a lot of interesting topics. So looking forward to those. Just a few words for the presenters. After you present, there'll be questions that'll come up. If you could read the questions before you answer them so that the question gets recorded. We are recording these sessions so that folks can look at the presentations at a later time. Everyone will have a total of 20 minutes for their presentations and questions, so be mindful of the time so we can get everyone through and finished at the end of the period. And I think that's it. So first up, we have Charles Kruger, who will be speaking to us today on survey methods and accuracy assessment comparison, a qualitative analysis for selecting an appropriate survey method. Charles, whenever you're ready, we can see your screen and we can hear you.
Okay, great. Thank you, Fritz, for that intro. As you said, I'm Charles Kruger, and my advisor for this project is Brian Neberezny. Thank you, Brian, for all you've done over the last year or so. As the title suggests, this is a assessment to determine the appropriate survey method. So we'll just kick this thing off here. The table of contents, just to give you a quick overview of what to expect. We're going to review the methods that were under consideration during for this project. We're going to look at the methodologies, the different types of assessments that were that kind of one way or another wound up determining, coming full circle and determining what we ended up using. It wasn't an exactly direct approach, so we're going to go through these assessments and finish it up with conclusion and discussion. So sorry for the word block here, but I just wanted to say that with today's rapid technological advancements, the price point coming down, economies of scale, and the miniaturization of various sensors, the survey or data capture market is constantly in competition. With so many options to choose from, it's hard for somebody who's new to the surveying industry to really know, if they're not familiar with it, what are the best methods for them to use and what will deliver them the product that they're looking for. As I said, in this study, we're going to look at a few different types and see if we can find a way to help recommend an appropriate method for them. The methods involved in this study, I'm just going to go through these pretty quick, are differential leveling. This is kind of the old school station rod and survey method that measures the difference in elevation between 2 points by having your fixed point in the middle and taking measurements to and from the linear feature. Essentially, differential leveling is a great method to use for people who survey areas a linear orientation. Total station is the next method. This method is the only method that doesn't require GPS. So a lot of these methods have their own little niche. This one, that's part of what makes this one special, is it doesn't require GPS. It utilizes trigonomic functions through a prism, and it has a sensor that captures the angle, the altitude, or the height difference between the point and the target. And you can, I didn't state it, but so far these are all going to be discrete points, which we'll come back to later. Global positioning systems, we all know, probably no need to get into detail here, other than just saying that it has its unique place where it fits in. You have to be careful with using GPS around electronic devices and metal structures. Next is the SUAS photogrammetry. Again, a lot of you guys are probably familiar with this, but This uses the science of overlapping photographs with side lap and front lap to create, basically you stitch the images together to create a surface that you can extract data from. Basically just measuring, looking at the photos before and after and tying it in to control points that were collected. It's a multi-step process. First you collect the control points, then you go ahead and capture the imagery and georeference those images to give you a measurable surface. This is the first of the methods that delivers a continuous surface. Next is the terrestrial lidar scanning. This is which we're going to get to the next. This terrestrial and aerial, we basically utilize this lidar technology, similar to radar and how bats echolocate based off of reflected sound waves from the receiver station. Lidar does the same with light beams, pulses of light, lasers, if you will. Similar to the other methods, to the total station, it measures the angle that the pulse of light was emitted and returned, and doing this millions of times in a given area gives you a high resolution image and surface that is measurable, and you can create 3D meshes from. You can create a whole host of interesting products. Again, that's a continuous surface. Here's a laserized, colorized point cloud from the laser scanner on your left compared to the high resolution photograph. You can see the detail that these LiDAR is able to capture. So then the aerial is essentially just LiDAR from an airplane looking down. You do have some issues with obstructions, overhead obstructions, but overall it's essentially the same technology. It's very handy for using large, for survey areas that are rather large. So the first approach was to look at the accuracies of these said methods and to compare the methods based on whatever sort of accuracy output is able to be achieved with that sensor. This is where basically the accuracy assessment came from, was to determine what the accuracies are of the methods. So to do that, we calculate, it was actually data that was collected from an experiment at the Black Walnut Grove experimental plot in Penn State, just down the street from Beaver Stadium. It's a it's a grove of black walnut trees that's bisected by a 24-foot wide, 1,600-foot long concrete culvert or swale that transports stormwater. So the data that was collected by the Penn State Mobile Geospatial Systems Group, and it was analyzed. Statistical analysis was done by myself for the purposes of this study. So for the Black Walnut Grove, like I said, the swale, there we took measurements, or sorry, the Mobile Geospatial Group took measurements, approximately 12 at 100-foot intervals. So you can see along the bottom the intervals, and a close up there. That is a mesh. That is collected with the photogrammetry from the drone that you're looking at there. There are 7 measurements collected along each cross section: left edge, top of left bank, bottom of left bank, center. You can see there where we basically collected the end points with the sensors. So those are tied in, but the other points, the top of the bank, the bottom of the bank, the center, those were not used. Those were not collected with. There were no permanent markers there, so basically it was a little less less able to achieve like a good lock on those inter control points, just because the nature of there were different people collecting. There wasn't, it was a kind of a educated guess, if you will, for what the center was or what the bottom was. We didn't have pins in place, so that's just kind of could be that's a good discussion item in my paper. But anyways, so we conducted the accuracy assessment, and we used the ASPRS vertical accuracy standards for digital elevation data to assess the accuracy, and we looked at the root mean square error to determine. Basically, we're interested in the relative accuracies of these sensors. We did not have a benchmark predicted value that we could use for to dial that in and be 100% confident of the individual accuracy of each sensor. We're more interested in the relative accuracies. So at the bottom, you can see here just a sample of some of the data that was collected. For the purposes of this, we used the direct leveling data set because it was consistent across all cross sections. We deemed that the good, quote unquote, data set. We used that for the predicted value in RMSE formula. So the RMSEs were calculated, and you can see that with the exception of the small UAS, the photogrammetry solution, all the others were about 7 centimeters. There's about a 7 centimeter range between the GPS, aerial lasers, total station, and terrestrial laser scanning, which is pretty good. It's pretty close, which I wasn't really expecting to see that. I didn't know exactly what to expect, but essentially we found out that accuracy from this, we realized that accuracies although these might not be reported accuracies for a survey like a final product, we could tell that they are all within roughly 7 centimeters, and that based on this result that we could tell accuracy alone is not sufficient for determining which survey method to use. So then we decided, well, if it's not going to be a quantitative approach from with examining the accuracy, maybe we can look at some other metrics and examine the metrics of the sensor, compare the metrics across the different sensors and technologies, and see which method would be the best for our analysis based on those metrics. So this factor table was made just kind of to get a sense of where the strengths and weaknesses, or where do these factors, cost, size, training, collection time, obstruction sensitivity, where do these factors rank compared to the other factors? The purpose of this was to try to get a sense of, like I said, the strengths and weaknesses, and this was used in our future, which you're about to see. We tried a couple different quantitative approaches. The cost-benefit analysis was kind of the first thing to look at that I was examining, but when you try to compare, we had a problem with the units. When you try to compare cost as a dollar value, as an example I have here, collection time as hours, size as acres, it's tough to compare these very different factors. Not to mention that they're kind of arbitrary as far as what people think is, for example, training, that's dependent upon a lot of different factors. So, so the unit problem we had kind of came into we ran into the same unit problem when we were looking at other methods too, to try to have a discussion about which sensor to use. We just kept running into this problem with units. So we realized that a standardized weight needed to be assigned. which is what led me to think about the max and min approach, decision-making approach, which looks at basically the losses and picks the option with the smallest loss. We were examining or considering the use of a radar plot where each parameter has its own axis, like training, obstruction, sensitivity, with a ranking number that would correlate. Essentially, would be the weight that that when we mapped them this way, you could see a certain area that would emerge for each type of sensor. And at a glance, we could see, if you're looking at a certain metric, what sensors do well with that metric. But we realized, again, you're going to guess, we had issues with these weights because the weights were, again, arbitrary. The results were inconsistent. How do you rank these in any dependable or repeatable manner? So essentially, the weights were similar to the units were an issue, which just made me realize we need to get away from a quantitative approach, and we need to start moving towards some sort of more of a qualitative approach. This is when I started thinking about it in a more kind of holistic way, and thinking about at the very beginning of the project, if you will, you know that you're looking for a certain type of data. So we started thinking about from more of a decision-based approach, what do we need, and let that, what exactly do we need, to let that kind of guide our decision-making process. As I stated earlier when I was explaining, there's discrete features or discrete points that are collected, GPS points, lat long on the ground, versus continuous surface that's made by a LiDAR data set. And that's usually going to be the determinative factor for a lot of cases. Data types and technology, as I said before, the linear corridor, you would use a certain type. If you can't have GPS, you would use another type. If you have a very large area, you would not use another certain type. So one question led to the next, and before long, I made this flow chart, considering cost and other things are already the same. I know I'm going to wrap this up real quick here. This is, and I'm sorry you don't have more time to look at this, but this is essentially what we came up for our final approach for recommending a survey method, starting with continuous surface. That's broken down right at the top. You have continuous surface versus discrete points. And then through a series of strategically formulated yes and no questions, you just run it through, and takes into consideration things like rugged terrain, overhead obstructions, linear features, hazards, legal things for flight, for legal requirements for FAA regulations for flight if you're using a drone. And this chart really did a good job to, it wasn't what we were expecting, but it led us to what we were trying to achieve. So, like I said, the accuracies, which was the first one, was a no-go once we dug into it. Because of the relative closeness that they were all able to achieve, the units were off when we tried to do like a cost-benefit analysis. How do we compare these units? So that led us to max and min for the weights. The weights didn't work, and so it was a process, and it took a lot of kind of just brainstorming to arrive at where we finally did with this flow chart. But in the end, the original purpose of the study was satisfied, and the approach was developed that helps people unfamiliar with survey technology determine what survey method could be right for them. And just discussion, I had a couple of things here. I know we're kind of short on time, so I don't know if we want to just kind of wrap that up, but discussion, looking at different options. There's more that can be done on the accuracy assessment, and that's in more detail in that paper. So here are my references. And is there any questions?
All right, thanks, Charles. Good job with your presentation.
Yeah.
While we're waiting for some questions to pop up, I'll ask one. Perhaps I misunderstood, but your accuracy assessment, did it combine the vertical and the horizontal component, or was it just one of those components? And then with your decision-making process, would the horizontal component add a different kind of accuracy assessment?
That's a good question. And yes, that sorry for not clarifying that. That was for the verticals. That was for the vertical analysis, for the vertical accuracy. The horizontal was not considered, mainly just because we were trying to measure the relative accuracy of that swale. And although the X and Y are definitely something to consider, and that would there were other tables for looking at X, Y, basically different errors that you would apply. And as far as combining them, yeah, that would have to be done in two parts. But for this purposes of this, it was just a vertical accuracy.
Okay, all right. Just wanted to check on that.
Thanks for clarifying that.
Maybe if you would just put your email contact in the chat so that if someone has a follow-up question, they could let you know.
Sure. Yeah.
All right, thanks. Yeah.
Yep.
And then, yeah, stop sharing and we'll go on to our next presenter for the day.
Okay.
So Ashley Coley.
Hello, can everyone hear me?
We can hear you. So if you want to go ahead and start sharing your screen.
All right.
All right. Next up, we have Ashley Piccoli, who will speak to us today on logging in northern spotted owl critical habitat. So Ashley, whenever you're ready.
All right. Hello, everyone. As just stated, my name is Ashley Piccoli, and I'm going to be talking about logging in northern spotted owl critical habitat. My advisor was Dr. Derek Lee, and he was very instrumental with helping me come up with the design for this capstone project. So huge shout out to him and thanks, that it helped a lot. And to give everyone a bit of a background on the history of the conflict and the situation with northern spotted owls as it exists, they were listed under the Endangered Species Act in 1990. Section 4 of the ESA triggers a critical habitat designation, which basically forces the Fish and Wildlife Service to create a critical habitat zone. And in that zone, whatever animal is, being protected has a lot of protections, which includes taking them. You can't kill this animal. You also can't harass them or modify their habitat in a way that would force them to leave, which is really what we're getting into here. Section 7 of the Endangered Species Act basically acts as a loophole for federal agencies. So, for example, in this case, the Forest Service can apply for an exemption with the Fish and Wildlife Service and be allowed to log within this critical habitat zone. And that's legally not a problem, as long as the Fish and Wildlife Service says it's okay. The northern spotted owls, they primarily utilize old growth forest, which is unfortunately exactly the same type of forest that loggers prioritize because it is high quality, it's high value. And that's really where the central conflict comes into play here, that both kind of need the forest lands that are on the Pacific coast. So my goals and objectives for this capstone were to assess the amount and proportion of logging that has been done from 2012 to 21, specifically on the U.S. Forest Service land within the critical habitat zone. And also to assess which type of logging has contributed the most to that habitat loss within the critical habitat zone. And kind of to talk about for a minute why this matters, any decrease in old growth forest does have a negative impact on the northern spotted owl as far as their reproduction and nesting are concerned. Also, this critical habitat zone, its boundary was revised in 2012, and there haven't really been any large-scale studies to try to figure out what logging has been going on within that zone since then. So that's kind of really what I'm aiming to look into here. And just to show you a bit of what this actually looks like, everything in the red on this image is the critical habitat zone on the West Coast. It spans 3 states, Washington, Oregon, and California. And as far as the methodology for this project, I started with data collection, which included 4 different layers. The northern spotted owl critical habitat zone, that boundary layer, the National Forest Service boundary layer. I also collected Landsat imagery and the FACS logging shapefile, which is simply a shapefile where the Forest Service has self-reported what they have been logging. And this shapefile is very comprehensive. I think it actually goes all the way back to the 1800s, although, you know, obviously that wasn't digitized until much more recently. And the setup for this, to help set everything up, I used the Mosaic tool to combine all of the Landsat images so that it's kind of compiled down to 1 per year to make it easier for me to utilize. I also clipped all of the layers together, specifically because what I wanted to look at was the logging that is, you know, specifically within the Forest Service, within this boundary zone for the northern spotted owl. So I clipped everything to make it exactly the study area that I'm looking for. As far as quality control is concerned, at that point, I spot checked the logging database against the Landsat imagery just to make sure that they accurately reported what they were logging and when they were logging it, and that they weren't logging stuff that was not within the data set, which, you know, thankfully they appear to have done a very good job with that. I also spot checked the critical habitat layer against the Landsat imagery, just to make sure there wasn't any built objects, such as roads, buildings, parking lots within that layer, because it's very important. I'm only looking at what is the forest land there. And thankfully, they also did a very good job of excluding that. So for the analysis, the first thing I did was separate all of these logging projects within the FACS logging database by year using a SQL statement and made them separate layers just so it's easier for me to sort through. And I also sorted it out so that I'm only looking at the 10 years for the study period. I then classified everything by adding a column into the attribute table of every single of the 10 logging layers and looking through every parcel that was identified and classifying these projects into commercial, pre-fire, and post-fire. I then opened the attribute table and extracted all of these area measurements from each logging year's layer by category. And I also did that to the critical habitat layer that was within the Forest Service. At that point, a couple quick calculations. I divided the areas logged by the total area, study area that I'm looking at to calculate the percentage logged per year per category. And for results, about 80% of the logging that was done within the study area was commercial. So that was quite a lot. 2.2% of the critical habitat zone for the northern spotted owl was logged in that 10-year period, which amounted to a total of 212,000 acres. And to give anyone a bit of perspective, there was a study done for the 20 years previous to what I'm looking at here. And within the Forest Service, within the critical habitat zone during that time period, they logged about 115,000 acres. So there was a significant increase during this time period. And just in case anyone wanted to see a chart of a bit of the raw data here, these are the acres logged for each category: commercial, pre-fire, and post-fire for each year, and then in total. Same thing with the percent. I also thought I'd put that in the slides here. It amounts out to about 2.2%. And here is a graph of what that actually looks like. One thing that I think is worth noting is that there was an outlier in 2016 for the commercial logging. I have no idea why it was so high. I think that's pretty interesting. I've been looking into it, but I haven't been able to reach any understanding of that. One other thing that I found interesting was that in every single category, actually, logging decreased in 2021. And I speculate that had a lot to do with the pandemic, as well as the logging markets and the demand at that point in time. And one thing that I think could be really useful in the future would be a high quality study on the effects of various methods of logging on northern spotted owl survival and recruitment. We know that pretty much any type of logging that you can do will negatively affect them. However, data on which types of logging are worse is pretty scarce, and it's not very comprehensive. And I think it's, from what I could tell, it's hard to draw conclusions about which type would definitively be best for the northern spotted owl. And that is very important, considering that about 80% of the logging that they did during this 10-year time period was commercial. Switching up, their methods of logging might be able to help the owl a lot if we can find one that's less detrimental to them. I also think it would be important to continue tracking logging within this critical habitat zone in the future. We are living in, I think all of us would agree, very volatile times right now. The COVID situation has gotten better, but it's still fluid. Geopolitics, there's a lot going on internationally and even nationally. And I think it would be good to ensure that in the future, especially since this critical habitat zone was again revised in 2021 at the end of the year, that people continue to just monitor the logging that's going on. And that is about all that I have for you all. Are there any questions?
All right, thanks, Ashley. Great job. And if you look in the chat window, we've got a question for you.
All right. Great presentation. You report that 22.2% of the critical habitat was logged. That doesn't sound like a lot to a novice like me, but I wonder how you would interpret your result. Is that amount of logging a problem for owls? Potentially. 2.2%, yeah, on the surface, it doesn't sound like a lot, but if you add it up over decades, it certainly will add up. You know, every year I was going through the data, it looked like just 0.02, 0.03%, but it does add up. And one of the things that I didn't mention in my presentation is that this is not the only stressor on the owls. This is a main one, but the barred owl is also in competition with them. It's coming further south. It's displacing them. Additionally, fires out west have gotten worse, and the frequency of fires specifically has increased over the past decades. So that's also potentially an issue. It doesn't kill them outright, but you know, it can damage habitat for sure. As well as fragmentation, that's one other thing that I read that seems to also be affecting them. So there's a lot of stuff that can hurt them in addition to just this, if that makes any sense.
While we wait for other questions to show up, I had a quick question. You didn't report on this, but I was wondering if you had taken a look to see if there was a particular, I don't know, county or region of a given state that had more impact on the owls. And I was thinking from this as a kind of a management strategy of someone saying, hey, you know, you need to decrease your logging in this particular county because it's having a greater impact on the spotted owl habitat.
I didn't look into that too much, although I am honestly curious now that you said that. I'd like to know the answer to that. Luckily, I think that should be pretty easy to find if I go through. The records were very detailed, so I think that would help. I would love to know what went on in 2016 that spiked all of that logging.
Yeah, that does seem a little
well.
Like a major anomaly there.
Yeah.
Well, any other questions for Ashley? Ashley, if you could put your contact info in the chat so that if someone has a follow-up question, they can get in touch with you.
All right.
And then you can stop sharing. We'll get ready for our next presenter.
Oh. Hold on. Oh, there we go. Okay.
All right, good. All right, Holly Golightly, if you're able to start sharing. All right, we see your presentation. So next up is Holly Golightly, who will be speaking to us today on spatial analysis of violent crime in San Antonio. We don't have any audio from you, Holly.
Okay, good morning.
There we go. There we go.
Okay, so my name is Holly Golightly, and my project is titled A Spatial Analysis of Violent Crime in San Antonio. And my advisor is Professor Stephen Matthews, and he has been amazing to work with. And this is the outline I'm going to follow, And in the interest of time, I will now discuss the background and motivating questions, including some background information on San Antonio. In my last presentation, I focused on a review of the literature and the theoretical background for the determinants of crime. To summarize, crime has an inherent geographical dimension and areas with similar characteristics often clustered together. Today, I want to emphasize that the determinations of violent crime are often influenced by the socioeconomic conditions, such as dense urban development, socioeconomic inequality, proximity to public housing, residential mobility, poverty, and the physical characteristics of the built environment. In this project, I utilized GIS and spatial analysis to examine the spatial patterns of the social and built environment and the determinants of violent crime. This includes exploring where violent crimes occurred in San Antonio, the spatial distribution of the different crime types, specifically assault, sexual assault, and family violence, and identifying the factors that influence these crime types and if there are spatial effects. The study area of this project is San Antonio, a rapidly changing city with a diverse population of 1.5 million. In this project, I look at the determinants of violent crime. This map of violent crime rates per 100,000 using data from 2017 through 2020 depicts the urban core and the historic north-south geographic divide. The data consists of violent crimes reported to the San Antonio Police Department from 2017 to 2020 and includes assault, family violence, sexual assault, robbery, and murder. The original crime data contains over 90,000 points. Here are the maps of assault, sexual assault, and family violence across the city. I convert the crime data to a polygon layer so that all data for this project is aggregated and measured at the census tract level. This analysis focuses on variables commonly utilized when studying the social determinants of crime. The data was acquired from the Southwest Texas Fusion Center, the Texas Alcoholic Beverage Commission, the American Community Survey, and the Esri Living Atlas, and the San Antonio GIS open data. The highlighted variables are included in the spatial regression models that will be shown later. After collecting the data, several data management procedures in Esri's ArcGIS Pro were used to organize the data. The latitude and longitude coordinates from the crime data were plotted using the table to point tool. The alcohol establishment's data was geocoded based on the street address of the business. Both data sets were aggregated to the census tracts using a spatial joint. The demographic and socioeconomic variables were added to the census tracts using the enrich analysis tool. The next step integrates the spatial data and applies visualization and statistical methods to bring insights to the crime patterns. Descriptive statistical methods, bar charts, and box plots describe the distribution of crime incidents Thematic maps, such as choropleth maps, help visualize the spatial patterns. For exploratory spatial data analysis, this project uses the open source software tool, Geoda. To measure the spatial autocorrelation, the local indicators of spatial association, or LISA method, identifies the localized map regions where data values are strongly positive or negatively associated with one another. The spatial autocorrelation is measured using univariate local Moran's eye. All tests use a Queen's first order spatial weight. Spatial regression analysis is a statistical method used to predict the relationship between one or more independent variables. This analysis utilizes statistical tests to see how well the independent variables statistically predict the dependent variable. Tobler's first law of geography states that everything is related to everything else, but near things are more related than distant things. This concept of spatial autocorrelation helps understand the degree to which one object is similar to other nearby objects. These cluster maps depict the results of a local indicators of spatial association. Low data values are spatially adjacent to each other as represented in the low-low class, while the high-high class has high data values spatially adjacent to each other. The Moran scatter plots show the relationship between the values of crime at each location and the average value of crime at neighboring locations. All scatter plots indicate a positive autocorrelation, which could have implications for the regression-based models. These are the LISA cluster maps for the salient X variables derived from the literature that are used in my regression analysis. They show the varying geographic patterns across the city and are coupled with the Moran's eye scatter plots, all revealing some degree of spatial autocorrelation. The steps for the regression models were first to run the OLS model, and then the next step was to check the assumptions, including the multi-collinearity and the spatial dependence, and then to map the OLS residuals. And then the next step was to determine whether OLS was the appropriate model or whether to run the spatial lag or spatial error model. While the parameter estimates from the OLS and lag models are very similar and the substantive interpretation does not change, the lag model includes the assault variable, and based on the log likelihood and likelihood ratio test indicates a better specified model. The spatial error model is included for completeness, but as revealed by the lack of significance of the lambda coefficient in this model and the likelihood ratio test, this model does not add much over the OLS model. Here is the OLS model, complete with spatial diagnostics for sexual assault. While there are minimal differences, the lag model is technically preferred, but when we compare the differences in the log likelihood as measured by the likelihood ratio test, this model does not represent a significant improvement over the aspatial OLS model. The Moran's eye of the OLS residuals is very low and insignificant and reveals no spatial dependence in the error term. And finally, in my third example, this shows the OLS model complete with spatial diagnostics for family violence. Again, there are minimal substantive differences in interpretation, but the lag model is the preferred specification. So what does this all mean? Assault, sexual assault, and family violence have spatial structure to their pattern in San Antonio. Both the built environment and social environment variables are associated with these crime types, while a substantive interpretation of the models and specific built and social environment variables did not change very much. The spatial diagnostics in all cases indicated potential problems with an OLS aspatial model. By including the lag-dependent crime outcome variable in the regression model, this provided a more reliable estimate of the other regression coefficients in my model. The models all revealed that alcohol outlet density was an important determinant of assault-related crimes, though its relative significance declines across assault, sexual assault, and family violence. In the case of family violence, area poverty and race variables are associated with higher crime rates, and area level educational attainment has an even stronger protective effect on crime rates compared to the other two crime types. There are several next steps this project could take, such as multiple crime types to analyze across different time intervals, such as in February, when there was actual snow in San Antonio and we went a week without water and power. That would be interesting to see how crime was affected. And there is more work to be done on the built environment variable, such as issues of skewness and in the outliers in busy places, such as downtown. There are more years of data to incorporate. I was unable to incorporate 2021, which would have enabled an investigation of the impact of the pandemic. There are other spatial regression approaches one could use, and I could have done a geographically weighted regression model, which would allow for more detailed examination between the built environment and social variables and crime across the city. And there's other models that use count data other than rates. And the last step would be to report my findings to the police department so they can initiate more community policing and crime prevention in the areas with higher crime rates. And here's my references and my data sources. And any questions?
All right, Holly, a very thorough capstone project. Great job with your presentation. If you could open up your chat window, there seems to be a few questions that have come up for you.
Let's see. There seemed to be one region in San Antonio that had the greatest crime rates for all models. Do you know why and which region this is? I think it's the east side of San Antonio, and it just has areas of high poverty, and that tends to cause higher rates of crime. Well, then I was born and raised in San Antonio, so this project was a particular interest. Your maps and analysis really illustrate the north side divide in the city. Yes, they do. Let's see, it looks like most variables show a north-south pattern, except race, which seems to vary from east to west. Any ideas why that particular variable has a different spatial pattern? I think it has to do with just the historical way the city has grown. The west side has just always traditionally been more Hispanic, and the east side has always just had a higher concentration of African Americans. My future goal with GIS, I currently work for the city of San Antonio for public safety. So I don't know, it's kind of nice working from home. So I may stay with the city or I may look elsewhere. Based on your findings, are you able to develop any predictive analysis as to factors that can reduce or prevent crime in high crime areas? That's a good question. They have what are called safe officers, and in the latest bond, they approved to add more safe officers. So hopefully just having the presence of police in high crime areas, hopefully maybe that could help. Your maps were beautiful. Thank you. Cartography will always be my first love. But, okay, I think any more questions?
Holly, if you could put your contact info in the chat window. So if anyone has any follow-up questions, they can email you later. That'd be great. All right, thanks again for a great presentation.
And then how do I stop?
So if you go up to the very top of your window, there should be a little green bar with a view options pull-down menu. There you go.
Okay.
Great, thanks. All right, next up we have Ashley Holman. Ashley, if you want to start sharing your screen.
Yep.
All right, we see your presentation and we can hear you. So next up, we have Ashley Holman,
Hello,
who
everyone.
is.
My name is Ashley Holman, and I am presenting Plugging into the Future, a case study in rural America. To start, I will give a brief overview of my project. I will start with a quick introduction, then provide some background information, the project objectives, the methodology, the results, the future steps, and then follow with any questions. I have been Northwestern REC's mapping analyst for the past 5 years. Northwestern REC is an electrical cooperative which was founded on providing electric to rural areas. The service territory of Northwestern is located in Northwest Pennsylvania. We have approximately 20,000 members and 2,500 miles of electrical line. One of the most recent projects that Northwestern has undertaken is purchasing a Tesla Model 3 to join our fleet vehicles, and they have also installed a level 2 charging station at the office for public use. I think that it is important to my project to read the mission statement of Northwestern. It reads, Northwestern Rural Electric Cooperative, as a member-owned electric service utility, will seek innovative ways to provide reliable and economical services to improve the overall quality of life in our areas of influence. The mission statement really illustrates how the member is the #1 priority of the cooperative. This slide shows the approximate area that Northwestern Rural Electric serves. I briefly want to cover the types of charging stations available. There are level 1, which is the slowest charging. It uses a standard 120 volt outlet and takes around 20 to 25 hours for a full charge. Then there is level 2 chargers. These use a 240 volt outlet. It provides faster charging, taking about 4 to 5 hours for a full charge. Then there is level 3 charging. This is the fastest charging available, and it takes around 1 hour for a full charge. The ranges of electric vehicles can vary greatly. On the low end, the Mazda MX-30 has a range of approximately 100 miles and is priced right around $27,000. On the high end, you have the Lucid AirDream that offers a range of 520 miles, but it's also priced at $163,000. Now, there are many vehicles in between the low and high end and moderately priced ones as well, but currently the median EV range is right around 250 miles. Next, we will look at the electric vehicles registered in Pennsylvania by zip code. You can see that the areas with a larger amount of electric vehicles are located in the urban areas of Pennsylvania. Pittsburgh is located in the southwest, and Philadelphia is located in the southeastern part of the state. This slide shows the current charging stations located in Pennsylvania. Again, you can see that the current EV charging infrastructure is mainly located in the urban areas of Pennsylvania. Now, zooming into the same map, you can see that there are a minimal number of electric charging stations located within Northwestern's service territory. The 3 previous slides clearly show that there is a lack of electric vehicle charging station infrastructure located in rural areas. In order to facilitate widespread EV adoption, these areas need to be looked at for this to happen. There are also numerous benefits of electric vehicles. One of the biggest being reducing greenhouse gas emissions and decreasing our dependency on fossil fuels. Pennsylvania Governor Wolf has also set forth an executive order that requires the state government to replace 25% of the state passenger car fleet with battery electric and plug-in electric hybrid cars by 2025. There have also been other states that have directed utilities to invest in transportation electrification. There are also benefits for electric utilities to take part in contributing in the effort to increase the EV market. An increase in electric load will lead to an increase in revenue for the utility. There is also a need to fill in the gaps in the current EV charging station infrastructure, which will help decrease the range anxiety that EV owners often face. The goal of this project is to identify potential locations for a level 3 charging station in Northwestern's territory. The suitability factors that were used for this project is number 1, being located within the service territory, then distances from other charging stations, EV ownership rates, population density, proximity to main roads, and proximity to existing power supplies. So again, the goal of this project is to identify potential locations for a level 3 charging station located in Northwestern service territory. This slide also shows the criteria and the data sources that were used. The proximity to Northwestern's power supply was obtained from Northwestern. The main roads came from PennDOT. The distance to existing EV chargers came from the U.S. Department of Energy. EV ownership was obtained from the PADEP, and population density was calculated based on 2020 U.S. Census data. The methodology that was used for this project consisted of identifying the suitability factors, data collection, and then the data analysis. To start, the weights for factors using the analytical hierarchy process AHP calculator were determined. Then, using GIS, the layers were converted to raster format. Then the raster files were reclassified for suitability. Next, the weighted overlay analysis tool was used on the reclassified layers, combined with the weights from the AHP calculator. And then finally, the resulting output raster identifies potential areas for an EV charging station. The Euclidean distance tool was used to create a raster on the existing power supplies. The areas that are closer to power are considered more favorable. This raster was reclassified using classes ranging from 1 to 5, 1 being unsuitable and 5 being the most favorable. The Euclidean distance tool was also used on the main roads shapefile. Areas that are closer to main roads are considered more desirable. This raster was reclassified with classes ranging from 1 to 5, 1 being unsuitable and 5 being the most suitable for this project. The shapefile for the existing EV chargers was created from the U.S. Department of Energy's Electric Vehicle Charging Station Locations Map. I used the multiple ring buffer tool in GIS and created buffers of 1, 5, 10, 20, and 30 miles around each existing charging station. The areas that are further away from the existing EV charging stations are considered more suitable. This was reclassified with classes ranging from 1 to 5, with 1 being unsuitable, which that would be the areas closer to existing chargers, and 5 being the most suitable, and again this would be the areas that are further away from the existing chargers. The EV ownership data was obtained from the interactive map titled Pennsylvania Registered Vehicles by Fuel Type and Zip Code. I was able to create an Excel spreadsheet only showing electric vehicles. Then that was joined to the zip code tabulation areas shapefiles that I downloaded from the U.S. Census Bureau. I then used the polygon to raster tool in GIS to create a raster of the EV ownership data. The areas that have higher EV ownership rates are more desirable for this project. This was reclassified with classes ranging from 1 to 5, with 1 being unsuitable and 5 being the most suitable. Population density was another factor taken into account for this project. I used the 2020 decennial population data from the U.S. Census Bureau. I joined this data with the census tract shapefiles that intersected Northwestern's territory. I then used the field calculator to calculate the population density of each census tract. The areas with a higher population density are considered more suitable for this project. I reclassified the raster with classes ranging from 1 to 5, with 1 being unsuitable and 5 being the most suitable. This slide gives an overview of the factors that I just discussed and the values that were used for reclassifying the data. The analytical hierarchy process was used to help determine the importance and weights of the different criteria in this study. This method is a pairwise comparison, which means 2 factors are compared against each other to determine which one is more important and by how much. This process uses a 9-point rating scale for criteria preferences, 1 being an equal preference and 9 being extremely favored over another factor. Distance to power supplies is the most dominant factor, which was given a weight of 41%. The second preference is given to distance to main roads with a weight of 30%. The distance to existing EV charging stations is the third factor with a weight of 13%. EV ownership becomes the 4th choice with a weight of 9%, and population density is the least preferred factor with a weight of 7%. The weighted overlay analysis tool in GIS is commonly used for multi-criteria decisions. The reclassified rasters and the weights from the AHP calculator were combined using the overlay analysis tool in GIS. This tool produced the final suitability raster, which can be seen on the right side of the screen. It was grouped into 5 classes, with 1 being unsuitable and 5 being highly suitable. After running the analysis, the final output raster identified several areas within Northwestern's service territory that would be ideal for an electric vehicle charging station. Now that the suitable areas were identified, I wanted to narrow down those results even further. To do this, I created a polygon of the suitable areas and then added parcel data to the map, and then selected the parcels that were located within those polygons. I then used land use codes to continue narrowing the results down. I selected parcels within land use code of gas station, hotel, restaurant, retail, and recreation that would offer existing paved areas to help lower the installation cost of an EV charger. This resulted in 20 parcels. Those parcels are identified on the map to the right as potential EV charging stations. I wanted to narrow the results down even more. Daily traffic volume was discussed in some of the literature that I reviewed, so I decided to add daily traffic counts as another deciding factor. The map to the right shows the 20 potential locations ranked high, moderate, and low, and these ranks are based on the daily traffic of the locations. Adding traffic information resulted in 9 locations, which are the most suitable. The next steps for my project will be sharing this information with Northwestern's management team. These locations will need to be field checked before a final decision can be made. Once a final decision has been made, I would like to share all of this information with our members to inform them of the ongoing project and to hopefully spark their interest in EV ownership, and to also show them that we are seeking innovative ways to serve them. I would also like to work with other electric co-ops and apply this methodology to their service areas to help them identify areas for potential EV charging stations. And lastly, are there any questions?
All right, Ashley, thank you for your presentation. Great job. While we're waiting for some folks to post questions, I have a quick question for you. I know in the literature, the AHP process in terms of determining the weights usually is derived from professionals. Could you comment a bit on how your weights were derived?
I basically derived my weights based on my thoughts and what I thought was the most important. I know that typically sometimes there'll be a group of people and they'll make that decision together. But for this project, I was the one who decided which factor was the most important.
All right, thanks for the clarification. If you could open your chat, looks like that you have a question.
Okay. So it says, I wanted to know if you thought your methodology could be applied to other locations. Anything more you could say on this would be great. Yes, I definitely think that this could be applied to different locations. Especially, I work with other co-ops within Pennsylvania. I would definitely like to collaborate with them, run the methodology on their service territory, and see if this, is a valid option for them as well. Any other questions?
All right, Ashley, if you could put your contact info in the chat window. If someone has a follow-up question, they can contact you.
All right, will do. Thank you, everyone.
Thank you, Ashley. Next up in our presentation list, we have Christian Coriel. Hello.
Can you hear me?
Yes, we can hear you. If you want to start sharing your screen.
Perfect. All right, and can you see my PowerPoint?
Not quite yet.
That's strange. One second, let me try that again. Is that any better?
Yes, very good, very good. Very good.
Perfect. All
So
right, sorry
next
about
up,
that.
no worries, no worries. Next up with our presentations, we have Christian Coriel, who is going to present to us today on CS-SIM, method of electric vehicle range simulation using powertrain modeling and convolutional neural network object detection. Christian, whenever you're ready.
Sure. Before I get started, talking about my software, I just wanted to take a moment to thank two people in particular, Dr. O'Brien, for his help with the review of my thesis, and also Beth King for helping me get this thesis over the finish line. I had some personal crises that caused me to have to stop studying for a little while and then come back, and Beth was just wonderful in assisting me. So thank you very much. So during this presentation, we're going to take a look at what CS-SIM is and the problem it attempts to solve, my software implementation of the basic concept, and some validation exercises that were used to examine the fitness of the two important elements that we decided to look at, or that I decided to look at. Finally, I'll discuss some future items that are planned for eventual implementation and answer any questions you may have. So to start off, I'd like to give you a little background. Currently, we're sort of in the nascent stages of the development of electric vehicles and their deployment at scale in large commercial fleets. So very early on. And due to the costs inherent and limitations of EV technology, large fleet deployments are very difficult. Starting with basic level 3 fast chargers on the low end, EV chargers with installation can cost anywhere between $75,000 to $500,000 for heavy duty vehicles. And as batteries get larger, charge times also increase. Development of intelligent charge strategies will be necessary to maximize the use of charge infrastructure and to minimize costs for commercial entities. Nothing is more fundamental to the development of a charge strategy than a basic understanding of the ability of vehicles to operate over an arbitrary route. CSSIM uses Python, GIS, ML, and science libraries to mimic driving behavior across a simulated road surface with a known grade. It interprets roadway instructions such as geolocated traffic signals and stop signs and executes necessary driver actions within the performance envelope of the simulated vehicle. In general, CSSIM works kind of the way that you do. It sees signals and stop signs when their location is not already known in the database, and it interprets roadway polylines, which are encoded with instructions such as speed limits. Driver behavior is determined by taking these instructions into account and conducting geodesic and general mathematical calculations to determine actions. From a programming perspective, the CSSIM software stack can be divided into two separate elements. The first and most important element is the server component, which was built using Python 3.8, the Django Object Relational Mapper, or ORM. For storage and geospatial queries, PostGIS was leveraged heavily. And then finally, the AI is based on the YOLO v5 convolutional neural network, and powertrain modeling is provided by NREL FastSim library. CSSIM is fundamentally designed to be integrated into the logistics systems of commercial operators, so the front end actually isn't needed. However, API Explorer was created to act as a testing tool to visualize responses from the CSSIM API. And this tool was built using the React JavaScript framework, Leaflet web mapping control, and Material UI. For global application state management, the Redux library was used. So to help you understand what this kind of looks like, instead of just talking about acronyms here, I want to show you a brief video of the software and the API Explorer. So here you can see we're kind of selecting a vehicle in the upper right. In this case, I chose a Tesla Model S60, and adjusting the charge percentage of the vehicle. You can also adjust custom usable range mins and maxes on the battery. And then we're going ahead and picking a departure point and a destination. So here I call this one simulation kind of dinner and hockey. So we're picking a destination point of a restaurant, or a starting point of a restaurant rather, and a destination point of Canada Life Center, which is the Jets hockey team stadium. So right now, once that information is submitted, the software is going out, it's building the route, it's looking at the intersections and doing AI object detection to visually examine those intersections using Google Street View data and developing a fully formed route. So here we are in Winnipeg. And then at the bottom, you can see the changes in elevation. And that's the result of our low S smooth elevation. And now here, we're looking at actual street level object detections from the AI. So here you can see, for instance, in this last one, it detected a traffic signal where no traffic signal was already known in its database with an 89% confidence. Now, once you hit the start button, the simulation will run. But if you noticed, the vehicle started moving almost immediately. The powertrain simulation was actually conducted in those brief seconds while you saw the window pop up that asked you to wait. So right now, this is actually just an animation that shows the output. And you can see in the upper right-hand corner, we have the speedometer changing speed and accelerating and decelerating as it finds stop signs and traffic signals at these intersections, which is fairly realistic driver behavior. And then at the bottom, you can see as we move along the route, we're looking at the elevation changes. Now these look like big elevation changes, but they're rather small actually, because Winnipeg's pretty flat. And you're only looking at like 1.5 meters between the min and max on that chart. So it looks big, but it's really not. All right, so let's move on. So the simulation you just saw was rather short. So the charge status change wasn't really all that obvious because it wasn't moving a whole lot. So to help you understand what the output looks like from the powertrain model, I have these two charts here. On the left, you can see the speed over time. So you can see the speed change and the acceleration and deceleration events occurring as the vehicle moves across the route. And then on the right, you can see state of charge change in the vehicle's ESS, periods where it's accelerating or driving at constant speed, state of charge is going down. For periods of braking, you can see that the regenerative braking is occurring with those peaks. So this is exactly what we would kind of expect to see in the behavior of the ESS in the vehicle. Okay, so next, let's talk about how this concept was implemented. Here you can see a list of GIS data sources. Virtually all simulation data, or at least the geo data, is retrieved from public APIs, such as Google Elevation, Bing Maps, OpenStreetMap, to name a few. And this decision was made so I could respond to user input for routes across the US and Canada without kind of first developing a massive geo database. Street level imagery for the AI to examine comes from Google Static Street View. To understand where the neural network needs to look at street level imagery, I first conducted a network analysis of all roads in the US and Canada that are present in the OpenStreetMap overpass API. Where possible, tags for stop signs and signal lights were logged along with all road intersections. This process is repeatable and takes about 24 hours to build a complete geo database on a 16-core server. The table that comes out of this process contains more than 14 million coordinate pairs. So here we're gathering where stop signs and signals are and where intersections are that have no tags. So one of the benefits of using PostGIS in this instance was to somewhat offset the relatively slow speed of the Python language. Postgres is written in a considerably more performant language, the C languages, C and C++. And as a result, I was able to speed things up by conducting many geographic operations there, such as buffers around line strings, by passing well-known text geometry in my geospatial queries. The image on the right is a visual representation of a network analysis of the Chico, California area. This was one of my study areas, as you'll see in a moment. For any neural network to work correctly, it must first be trained over many, many hours of computer time on sample imagery. To improve accuracy, the YOLO V5 neural network uses an evolutionary algorithm to optimize what's called hyperparameter fitness with the most performant mutation seeing implementation. So the hyperparameters are kind of settings that affect the training of the neural network. At the end of this procedure, 150 hours of evolution on a NVIDIA A6000 GPU were required, which is a very special piece of hardware, along with about 63 hours of training on a Vega 20 GPU. So the chart above shows the improvement in mean average precision, or MAP, across YOLO V5 variants as the final training progressed. So this is the evolved, these are the evolved variants. In this slide, you can see how the route development pipeline kind of fits together. When the user enters the departure point and destination, a route is retrieved from Bing Maps. This route has elevation data and road grade data added by low-S regression of Google API elevation values. A buffer operation is conducted on the POI database to geolocate stop signs and traffic signals, which will affect vehicle behavior. Eventually, the neural network conducts inference against Google Street View imagery for intersections with no instructions. So not all of the instructions for traffic signs and signal lights are present in OpenStreetMap. In fact, there's many of them missing, especially in the more rural areas and in southern Canada, where I was living when I started writing this software. So lastly, kind of here at the end, all of these data are fused into a complete route object. To characterize acceleration and deceleration performance, real-world data are run through a curve fitting exercise using the NumPy polyfit function. This produces a high-order polynomial function which closely resembles the data source. So with speed on the y-axis and time on the x-axis. The application that calculates—
Christian, could I interrupt you for just a minute? Mark Mercer, if you could mute your mic, your background noise is interfering with the presentation.
I'm very sorry. I had no idea the mic was on. Thank you for letting me know.
Thank you.
So this produces a high order polynomial function, which closely resembles the source data. So here we have, in this chart, we have kind of the speed on the y-axis, time on the x-axis. The dots are the data from a test report on a heavy-duty vehicle. And Polyfit created this high-order polynomial, which approximates those data pretty well. So then, using a little bit of calculus, we can determine the distance traveled based upon time. For distances across the route, as opposed to these acceleration or deceleration distances, Vincenti's inverse geodesic method was used. Once the fully formed route is obtained, CS-SIM Action Builder interprets the instructions and produces actions. These actions are then sliced into individual seconds of vehicle behavior for powertrain simulation. So that's kind of the output to FastSim, is actual individual seconds of this is what the vehicle should be doing at this second. So this image kind of gives you an idea of how this interpretation process works, with the vehicle starting its journey in a 25-mile-per-hour school zone. At some point along its route, the prevailing speed limit increases to 45 miles per hour. However, in this case, CS-SIM correctly determines that it can't actually achieve the requested speed and stop in time for an object detected signal light. So as a result, Action Builder looks at this, says, I can't comply with this instruction from the road. So it determines kind of what the maximum speed it can reach within its performance parameters is, and it achieves that speed, and then it decelerates to a stop. Validation. So as part of this project, I chose to examine some aspects of CS-SIM to make sure it was performing as expected. The first validation exercise consisted of the examination of neural network performance in Chico, California. So here I examined how often CS-SIM correctly determined what I call the highest order object. So in an image with multiple detections, one object may take priority over another. So for example, if I'm approaching an intersection with a stop sign and there's a speed limit sign right there as well in the same frame, obviously the instruction to stop would be higher order than the instruction to change speed to the new speed limit. So here the stop sign would be the highest order object. I'd also like to take a minute to note that the AI training library only consisted of about 6,000 image annotations and 4,000 images, whereas about 73,000 image annotations are actually recommended for the 73 object classes I use. So while the neural network, it's kind of interesting, the neural network was significantly undertrained, but despite this, I believed it would be sufficient for this proof of concept, and it was. It worked out pretty well. So here we can see the AI perform well despite the limitations we talked about. And in the traffic signal category, it achieved about 93% accuracy, which is pretty good, especially given the circumstances. So many stop sign misses weren't actually misinterpretations by the AI. They just weren't relevant to the vehicle because in the Chico area, there are side roads and frontage roads, and it was picking up a stop sign that was on a frontage road. So it was actually a little bit too sensitive. And also in the pedestrian crossing class, which is a very important class for a simulation, there were just very few training images. So I expected that performance will increase dramatically as the training data set grows. So given these facts, the AI really exceeded my expectations given the short training duration and the limited set of data that it was trained on. So the second set of tests were designed to look at the quality of Google elevation data that I used. To improve upon these data, I implemented what's called locally weighted regression scatter plot smoothing, also known as LOS. I tested various LOS smoothing fractions and determined the value with the lowest root mean square error. In order to calculate an RMSE, you need ground truth value to compare to a LOS prediction. So here I used USGS LiDAR for the Morongo Valley, California area. This is out in the desert. There's not a lot of foliage. So it was a good candidate. Results from LiDAR examination show the minimum RMSE of 1.49 meters at a LOS fraction that included the nearest 20 points. This equates to an error of around, plus or minus almost 1% grade. So that's not terribly good. While this result was pretty underwhelming, it's probably a worst case scenario. The region I selected had a very high, extreme change in elevation over a relatively short distance. So in short, this test kind of likely illustrates the upper boundary of Google of LOS smooth Google elevation data error. Ultimately, the LOS smoothing data outperformed the raw data significantly. So I think that demonstrated the utility of the algorithm and its ability to kind of smooth out the extremes and spurious data points. And I think that worked pretty well. So last, I'm going to talk a little bit about the future. CSSIM is presently what I would consider to be a well-developed proof of concept. It provides a basic architecture capable of solving the underlying problem. Future development will definitely be necessary to make this a useful tool for service providers. So the most significant likely improvement in the near term is the implementation of a probabilistic stop or traffic signal model. So right now, traffic signals and stop signs are all treated as a complete stop. So here I intend to use images from each direction of the intersection and a technique that's called AI image segmentation to determine the number of lanes. This will increase the accuracy of the model. With improved object detection, this should allow the model to configure itself to more realistically approximate ground truth. And then lastly, there's kind of a few other areas of improvement. First, improved localization and support for regions outside the US and Canada. This is very straightforward. It will just require region-specific AI that's been trained for, say, Europe, and an instruction order of precedent that functions well with their traffic laws. Traffic congestion, support for this has already been built into the application, it just hasn't been implemented. And this will be accomplished by injecting speed change instructions along the route after the POI points have been extracted from the database. And kind of interestingly, this could actually be informed by a real-time traffic monitoring system. And then lastly is just kind of base performance optimization. There's been almost no performance optimization done here, except what I said about how we leveraged PostGIS. I believe an order of magnitude improvement is definitely achievable, and just some ways that we can do that, because this list is, in actuality, is very long. So I kind of picked some of the top three. Would be performance optimized Python interpreter, which there are several of them exist. Parallel image retrieval is probably the biggest one. When it's pulling the images down from Google, it's doing that sequentially, and it could be pulling several of them down at the same time. And then lastly, if the server application is located using Google Cloud infrastructure, it would be closer to some of its sources of data, and that would reduce latency. So that kind of wraps up the presentation. Hopefully I adequately explained what the application is, kind of how it works, and some of the GIS technologies that we're implementing.
All right, Christian, thanks for what is a very impressive project. Very impressive. Great job. While I wait for a couple of questions here, I have one. I don't know that you necessarily addressed it, or even if it's possible, but to give a better estimation of travel time, is there any way that you could integrate like real-time traffic feed in terms of congestion or construction or other kinds of barriers to smooth travel?
Oh, it definitely, you can. Interestingly, kind of what I'm looking at, there's two things that are similar to one another. One of them is going to be the traffic, and the other one is going to be weather. So for passenger vehicles, weather isn't all that important, but for heavy duty vehicles or transit vehicles, it is, because HVAC is a considerable draw on the ESS. So I am actually, for both of these things, looking at not just informing the model based upon current traffic, but historic traffic. So fleet operators can go back and look at that day that there was a really bad traffic incident and see how it affects their range, or that day the temperature was really low and see how it would affect the vehicle performance.
Oh, okay. Yeah, that's interesting. I didn't
So
think
yeah,
about
not just current, but historical.
Yeah, okay. Yeah, good, good. Does anyone have any questions for Christian? All right, well, Christian, if you could put your, yeah, there you go. You're one step ahead of me. So thank you very much for your presentation.
Well, thank
And
you all for taking the time to listen to it.
so next up, we have Patrice Case. Patrice, if you want to start sharing your screen.
Okay.
All right, we see your screen and we can hear you.
Okay, cool.
So our next presenter is Patrice Case, who will be presenting today on how many firefighters do we need? Whenever you're ready, Patrice, it's all yours.
Okay. Yeah, so my capstone project is how many firefighters do we need? The idea for this project came about my own personal experience being a volunteer firefighter EMT in the study area, which is Jackson Fire District number 3, which is located in Jackson Township, New Jersey. I wanted to use GIS to understand more of the fire district and figure out things that the fire district might need in the future. So to give a general overview of what the fire district looks like, it's about 10 square miles and has a bunch of different features in it. So you have industrial areas, you have a major highway running through it, you have apartments and condos, a lot of different things going on all at once that require different or may pose different hazards to firefighters responding to incidents in certain locations. All the data was obtained through the New Jersey Geographic Information Network. I used parcel data that's updated yearly off of tax information. And the boundary for the fire district was created by me going in and creating the boundary. So the certain statistics that exist in this fire district, there's almost 8,000 residential houses, there's 3 schools, 5 apartments, 3 condos, 2 55 and up communities, 1 major highway, farms, chattel property, commercial, industrial, and assisted living. There's a lot of different things that go on, and these different amounts of locations matter because you need different response for these locations. So for your average house fire, you're going to need not as many firefighters as you would for a commercial building that's like a food store or a home improvement store. You're in different resources for each thing. So that goes into later on going into and seeing if the amount of current firefighters that are staffed meet the standards to fight fires if they were to occur at these type of locations. So Jackson Fire District number 3 was established on January 17th, 1956. They have currently 13 full-time firefighter EMTs, and they're staffed from 6 a.m. to 6 p.m. Monday through Friday. From 6 p.m. to 6 a.m. Monday through Friday, and then weekends is all volunteer response. So if there's an emergency in the fire district from 6 a.m. to 6 p.m., you're going to get a career firefighter that's responding from the firehouse. From anytime after that, and on the weekends, it's going to be a volunteer responding, which to me was something that I didn't understand or know about until I got into this type of field and realized that not every firefighter responding to an emergency is career, or they're not all volunteers. There's a difference in certain areas. So with all of this, there's a new need that the fire district has, where the fire district is funded through taxpayer money. And there's certain things in the fire district that are starting to fall apart, like certain fire apparatus needs to be replaced, new tools need to be bought, and more firefighters need to also be acquired. But with all that comes from the fire district budget, which if the public votes no on this budget, the budget doesn't pass, and that money doesn't necessarily come from the taxpayers, but comes from some other place in the government if it can be found for that town. So with that, buying a new apparatus and a new fire truck or new ladder truck is an expensive cost outright. A new ladder truck can be almost $1 million. A new fire engine costs, $500,000, which honestly is probably more during this time where things kind of cost more and take longer to build because of the lack of supplies and resources. So once these type of items are purchased, they should last almost 30 years, which is also kind of the same lifetime of, well, that's not a good way to put it, but the same time that you'll have a career firefighter that will retire after 30 years. So these type of costs kind of coincide with each other, with how you pay up front right away, but then they last you almost 30 years, if not more. So with that, Jackson Fire District number 3 has a multiple of different apparatus, and a lot of them are old. There's currently one being replaced, and that's going to be replaced with a brand new engine, but there's apparatus that are from the early 90s that need to be replaced, and the money isn't there to replace them. Which visually looking at them, they look like just regular fire trucks. You can't tell if they're super old or out of date. They look pretty decently new. But on the right-hand side, the top right corner picture is the old engine that's being replaced by the picture right below it, which is a brand new one, which if you didn't know the difference, it would kind of look like the same thing. But the one up top is old and falling apart, and the new one is going to hopefully last 30, 40 years, hopefully. But this becomes important because it's a cost to the fire district that can take away from having career firefighters be utilized, because there's different choices and different things that need to be addressed first before hiring more firefighters. So Jackson Fire District number 3 is the fire district, and then there's Jackson Township Volunteer Fire Company number 1, which is the volunteers. So the volunteers and the fire district kind of work together, because the volunteer fire company was established first in 1951. So there's 40 active members, and these volunteer members respond whenever they can, but only cover the fire district from 6 p.m. to 6 p.m. and on the weekends. So they also operate on duty crew schedules. So you're not just every night, you hope someone comes. Like, there's people that are scheduled to sign up and respond, though there's no guarantee that they may respond because they're volunteering their time and there's no repercussion if they don't show up. So with this knowledge and knowing this doesn't necessarily always mean like you're not going to get 40 volunteers responding to every single call. You'll probably get around 10 or 15 based on what people are doing, because they're volunteering their time, and whatever time they have to give is free time to give. Meanwhile, with a career staff, those people are in the firehouse working and are ready to respond from the firehouse. So with that, looking at the Jackson Fire District 3 budget from 2021, a new firefighter at the fire district starts out at almost $39,000 a year, which is kind of crazy low because the average firefighter salary in New Jersey is around $54,000 a year. So that's a topic in itself. But the estimated total cost to the fire district for the first year of hiring a new firefighter is almost $70,000. That's including their health insurance and the fringe benefits. So the first year start out cost, a super rough number of $70,000 for one new firefighter. You take that and compare it to the cost of the new apparatus. It's the firefighter seems more cost efficient than buying a new apparatus when they both kind of last the same amount of time. But they're both needed because the fire district purchases all the material and the apparatus and the tools, and the district uses it, but also the volunteers use it as well. So that's another factor to keep in mind. So in 2021, the fire district hired 2 new firefighters at that starting salary. And then when they're hired, they usually join a union, and that union works with the fire district to create a contract. And that contract outlines the firefighters' raises over the years, meaning that when a firefighter retires from the fire district, they can retire at 6 figures. So in 2021, the budget had that 6-figure amount budgeted to hire a firefighter, but there is no firefighter hired to that line item. So that money is there. They have it set up so that they were paying somebody that amount. That person retired and that money went somewhere else in the budget to be utilized to buy tools, go towards a new apparatus, or go towards something else that was a higher priority than hiring a new firefighter to replace someone that retired, or hiring 2 new firefighters to replace someone that retired based off of the salary amounts. So with that, the NFPA, which is the National Fire Protection Agency, creates guidelines for fire companies to go by. It's kind of like OSHA in a sense, where they create these guidelines and they test them, and they make sure that if you follow these guidelines, you're creating a safe working environment, or you're creating an environment that is as safe as you can make it by following these guidelines. So there's no law saying that anybody has to follow these. They're just guidelines, but it's heavily suggested that you do follow them. Because if you don't follow them and a firefighter passes away in a fire and there wasn't enough firefighters, or they didn't really meet the NFPA standards, that person's family can go sue the fire district and say, you didn't do things the right way, you didn't follow the NFPA standards, and that's why, this firefighter died. So according to NFPA 1710, it says that for adequate engine staffing, each apparatus must have a crew of 4 firefighters. And most apparatus can fit around 6 firefighters in total, with rescue trucks, which rescue trucks go to like car accidents. They can fit more than 10 firefighters at once. And NFPA 1710 also goes into detail about how many firefighters are required to fight different types of building fires. So for a single family dwelling, just like your normal average house, NFPA says that you should have 14 firefighters, 15 different aerial devices used, which an aerial device is a ladder truck, something like that. In open air strip malls, 27, garden style apartment, 27, and high rise is 42. Jackson Fire District number 3 has single family dwellings, strip malls, and garden style apartments. There is no high rises, but there are areas that they would go to that do have high rises. As like mutual aid, if another department needs help, they would respond in to that area. So with that being said, a single family dwelling requires 14 firefighters to meet the NFPA standard to fight that fire. As of right now, Jackson Fire District number 3 only employs 13 career firefighters. So if a fire like that happened during the day, you would get, if they were all on staff, 13, but not all 13 firefighters are staffed every day. They work in shifts. So they work in shifts out of each station. There's 2 stations in the fire district. So you'd have 4 coming from one station and 4 coming from the other station. So you'd only have 8. But with that being said, there's also, if you have a fire happening in one part of the district, you're going to have mutual aid come in to assist with that fire. So there's 3 other fire departments in Jackson Township. One of those would come in and assist in the fire and then meet the NFPA standard. But with that being said, multiple different fire companies are already dealing with their own issues in their own district, where they may already be on a call and may already be mutual aid somewhere else, and then they may not be able to come to a fire and help and give aid if they're already busy somewhere else. And then if they do leave their district and come and give aid, they need to have someone cover their district in case they have a call and need to respond to something going on in their district, which kind of creates this domino effect of a problem where you send someone somewhere and you need to keep covering until every town is covered and has someone to respond to an emergency there. Which this came into play on March 14th, 2021, which there was a 167-acre brush fire that burned in a super highly populated area of Lakewood and Brook Townships in Ocean County, which Lakewood is right as a neighboring town of Jackson. So Jackson Fire District 3 was called in as the rapid intervention team, which is RIT. They are the ones that would go in and rescue a firefighter if a firefighter went down in a house fire. They were called in for a structure fire caused by the brush fire, and then ended up helping fight the forest fire. So this was a Sunday, and because it's a Sunday, it's all volunteers, there's no career staff. And this ultimately left the fire district with no one in district to respond to a call, because all the volunteers originally went to the structure fire in Lakewood to help as RIT, and they were called in to help with the brush fire. And then after they were done at that first call, acting as RIT, they ended up going and helping with the brush fire and meeting up with the other crew that was already there. So this left the district without anybody, and ended up having to have someone else from a neighboring town come in and cover the fire district until they got called in to Lakewood to help fight the brush fire. So that left no one able to cover the district and no one able to cover the other fire department that ended up covering the fire district. So it's this domino effect of finding people to cover. And what ended up ultimately happening is that the Burlington County Task Force came to give coverage to the fire departments fighting the brush fire, which Burlington County is a county in South Jersey, nowhere near Ocean County or Monmouth County, where departments were being called in to help fight this brush fire. So because of that, it kind of opened eyes to realizing that if there's not enough resources in one area, and you keep pulling resources from that area, you need to find ways to cover those resources displaced, and figuring out the best and appropriate way of doing that without scattering the entire state of fire departments. And also with this, the volunteer fire chiefs can call a recall, which calls the paid staff on, which happened during this. So this had all the volunteers and the career staff on helping to fight fires on this day. So this whole overall incident really showed how badly things can go if a lot of bad things happen on one day, and also showed how there's not a lot of resources to give on situations like this. So with this, as population increases in the Jackson area, more incidents occur because more houses are being built, more people are moving, and more things are going on. So the population in Jackson Fire District number 3 has kind of been weird over the past 10 years. It went down in 2014, but it started to increase at a pretty steady rate up until now, which are almost at 25,000 people, which this population increase means that more houses are being built, more people are moving in, and there's more changes going on. And so as that happens, as the town grows, usually the fire district grows too, except that it hasn't happened in this case, where no new firehouse has been built, no new apparatus has been acquired to add in until it's been acquired to replace outdated fire apparatus, and the number of career firefighters has not gone up in 10 years. The number of career firefighters has stayed the same, and has stayed the same from before 10 years too. The same number fluctuates. If anything, it never goes above, it always goes under. And so with that, as buildings are being built in the fire district, newer buildings are built cheaply. They're not using solid wood, they're using this manufactured wood that is just pieces of wood tightly compressed together and glued together, and that burns quicker. And new furniture burns quicker too, because it's made cheaply. It's not made like it used to be made, where everything was solid wood and had a lot of time and effort put into it. Now everything it looks good, but it's cheap and quick and fine, but it burns a lot quicker, which means that houses burn quicker. And so because houses burn quicker, having a fully staffed career fire department on call means that there are already firefighters at the station waiting to respond, rather than having volunteer firefighters coming from their homes or wherever they are to respond to the firehouse and then respond to the fire. Which that doesn't mean that volunteer firefighters are not needed. It just means that they may not be the first engine on scene, but possibly the second or third to bring more help. And if they're not needed at the call to begin with, they can always stand by at the station and be there to cover the station in case there's another call. eliminating the need to call coverage in from other towns to remove firefighters from one area to give them to another area. And so with this, NFPA 1710 says that an 8-second turnout time and a 4-minute first engine arrival time is a suggested time to respond to an incident. So that, putting that into effect, 8-second turnout time means that you have 8 seconds to get dressed and get in the truck and respond out of the firehouse, and 4 minutes to get to the scene. And using ArcGIS Online in their drive time analysis, you can see that that doesn't necessarily affect or completely cover the fire district. Using the 2 stations as the starting points and then using the truck time as the option to do the analysis, realize that there's a whole section of the fire district that you can't reach in 4 minutes. So using Esri's drive time analysis and looking at that area and knowing information about the area and seeing there's a vacant lot at this one spot where I chose to have the 2nd or the 3rd firehouse, adding a firehouse there increases where you can go in 4 minutes from a call and covers a lot more of the area. And add another firehouse. It also covers area going into Lakewood, which is from the right bottom corner of the map, which is a place that Jackson Fire District Number 3 goes to a lot for mutual aid calls. So it would allow for more coverage, create more space for firefighters, and allow more apparatus if a new firehouse was built at this location. And then an MFPA report titled U.S. Fire Department Profile in 2019 states that communities of 25,000 people or more had median rates of 1.54 to 1.81 career firefighters per 1,000 people. So Jackson Fire District Number 3 is almost at 25,000 people. So if you take that ratio and apply it, that gives you a number around 38. So using this ratio and comparing it to other places in the United States, it means that Jackson Fire District Number 3 should have 38 career firefighters, which is a pretty big jump from the 13 that they currently have. So if the fire district was to hire 25 more firefighters to meet that ratio, the cost to the fire district would be a little under $2 million at a super rough estimate, using the budget numbers and doing all that math. Which if you take that, divide it into the population of the fire district, it comes to about a $70 increase in annual taxes for each citizen. So, which that isn't a crazy amount. It's probably the cost of it to fill up your car right now. But to taxpayers in town, they don't want to see their taxes increase, and they see that and they see that it's only going to go higher in the future, which is ultimately going to happen because as the town grows, more money is needed to help protect the town and protect people's houses and protect people. So creating that and kind of understanding that, and as that number grows, more things can be bought in district. So, you know, you could build a new firehouse, you could hire more firefighters to fill that firehouse, and more apparatus and all the other fun things that come with having the money to do it. And to realize that these needs need to be met to meet the NFPA standards to create safe firefighting environments or make them as safe as they possibly can be. So next steps for this would be to do more research into how much money this would exactly cost the taxpayer over the next coming years, and doing all of the math involved, understanding the raises and the annual cost and what the amount would be at the end. And then to also do deeper research into seeing where a new firehouse should be located based on future predicted growth. As of right now, that one location that I showed seemed pretty, smart based off of different factors, but may change in the coming years as the town grows more. And the last step would be to present this to the Board of Fire Commissioners for the fire district and see what they said and see if they have any thoughts or if this motivates them to actually do something to change the fire district and to start growing it more or growing it faster than compared to how it's been growing. And that's it.
All right, Patrice, thanks for your presentation. Great job. Does anyone have any questions for Patrice? So while we're waiting for questions, I'll ask a question. So your costs that you talked about was just the physical cost of hiring new personnel. What would be the cost of building a fire station, equipping it, maintaining it? I mean, that has to get added into the equation too, doesn't it?
Yeah, and that's all dependent on what is to be included. That's like if they want to make it only a firehouse that operates fire engines instead of fire trucks. So there's only there's not ladders, there's only like engines coming out of it. That could make it the cost cheaper or more expensive, or it could be like a small substation where it's just a little 2-bay firehouse that only responds out with a, 4-person crew. It really depends on all the different factors that would go into it and to decide that amount. But it is something that could be looked into for the future to see how much that cost would add on to the additional
Yeah.
cost.
But I think that would be an important factor too. Like you said, everybody wants the services, but no one wants to pay for it.
Yeah.
Looks like you have a question in the chat window.
Yeah, so the question is, you are very knowledgeable about this topic. If you presented to the fire commissioners, do you have high hopes they would invest in more career firefighters? It could go either way. They understand right now that there is a need to hire more firefighters. They just don't know how to approach the problem of not having the money to hire them. That's how I kind of see it right now. If I do present this to them, it would most likely get their the wheels going in their head to be like, okay, we do need to do something about this. But unfortunately, I don't think it would really like jumpstart them to do anything intense right away, just because of all of the other factors they have to deal with right now in the fire district.
All right, Patrice, if you could put your contact info in the chat window. And thank you very much. Again, great job. Next up, we have Stephen Coleman. Stephen, if you want to start sharing your screen.
Can you hear me?
Your volume is really low.
Yeah, I'm gonna turn my mic up. Okay, is that sharing now?
Yeah, we're sharing and we can hear your volume a lot better.
Okay.
So next up, our last presenter for the day is Stephen Coleman, who will give us a presentation on site selection for suburban and peri-urban micro farms. Yeah, we're not hearing any audio right now. Stephen, if you can hear me, we're not picking up any audio.
Can't hear anything?
I can hear you now.
Okay, I can start over. Is my screen still sharing?
Yeah, screen shares fine.
Okay. Oh, sorry, 1 second. Okay.
All right, we see, yeah, we see your screen. That's good.
Okay, so earlier during the pandemic, some of the things we saw get disrupted was food production and transportation because workers weren't available to harvest crops from large farms, and we didn't have enough drivers to deliver produce when they were available. That became a problem because certain fruits and vegetables are having to travel further distances to reach average consumers, sometimes more than 1,000 miles. One of the positive things that came from that was that from the pandemic was that people began to discover new interests, one being edible landscaping, which is just growing plants in your yard for the intent of eating. And so once the pandemic began to settle down, some normalcy started to return. A lot of these gardens started to become afterthoughts. And for some, the opportunity, it became an opportunity for others. The idea of becoming a farmer became a real interest to some people, and that's who I wanted to focus on. People that want to become farmers, but don't have the land or the resources to do it. And I wanted to focus on finding residential properties in suburban areas because it could be a good place to start from for new farmers on a low budget. Residential areas have existing access to sewage and water. They have a yard space that is small enough to be managed by one person with hand tools that are cheap, and potential markets that are nearby, like farmers markets and grocery stores. The study area I focused on was where I grew up in, Chesterfield, Virginia, which is a pretty large suburban county just outside of Richmond. It's somewhat bordered by the James and Appomattox rivers, and the county falls within a segment of the eastern side of the country, known as the Piedmont region, which is known to have open grasslands and forests, large reservoirs, hilly areas. And before becoming a suburban area in Chesterfield, it was a very rural area. And as of 2017, there are still about 210 farms that still operate in the area. Most of the data I collected was from the county's GIS website, geospace.chesterfield.gov. And the main layers I downloaded for the project were the county border polygon layer, the zoning layer to display which areas could be designated as residential, and parcel layers to show private residential properties. And I also downloaded an elevation raster from the USGS Earth Explorer. To prepare the data for the project, I started with clipping the extent of the elevation layer to the county boundary layer and using the extract by math tool. Next, I needed to identify the aspect of the county's topography to determine the direction of the surface, and the ideal direction being south-facing parcels. Next, I wanted to determine the slope, so I did so using the slope tool, with the ideal slope being a gentle one of 7% or less to allow natural drainage and limit erosion. And finally, I wanted to determine the hillshade surface of the county to identify parcels that received an adequate amount of sunlight, ideally 6 hours or more for most things that you would grow. It was important to find locations that received as much sunlight as possible. So I looked up the azimuth and altitude from the Global Monitoring Laboratory of the National Oceanic and Atmospheric Administration. My results, to get my final results, I wanted to use the raster calculator to determine which parcels would be the most suitable based on the criteria of the prepared maps. So I used a model builder in ArcGIS Pro to reclassify the map. The aspect map needed to show, like I said, south-facing parcels. So I included south, southeast, and southwest facing areas to to ensure that any crop grown will receive as much sunlight as possible. Next, I reclassified the slope to show only slopes that were above or below 7%, where slopes that were above 7% could be acceptable based on certain crops. But most general slope of 7% or less was enough for crops that like salad greens and using a raster calculator, I used to find parcels that met the parameters. The hillshade and aspect surfaces were assigned an equal level of importance due to their association with sunlight being the most important factor. And my result was this. And that's everything. Any questions?
All right, thanks, Stephen, for your presentation. Good job. Anyone has questions, they can put them in the chat. While we're waiting, I have I guess kind of a basic question. So you looked at slope and aspect as your kind of key variables. Would you think that perhaps, I don't know, other things like soil or precipitation would help maybe narrow down the selection of your proposed locations?
I did consider soil, but I decided not to include it because even though some areas might need maybe soil remediation, I thought I wanted to be like more inclusive of any potential areas. I think if I were using maybe more the Richmond area where the soil is maybe more contaminated by being in the city, I might have considered soil as an option. I did try to look for land that was within a certain amount of acreage because I wanted small properties that weren't larger than an acre. But I had trouble finding the deeded acreage on residential areas that were like in planned neighborhoods that had like an HOA. And a lot of the places that listed the acreage publicly were already designated as agricultural land.
All right, okay. Well, thanks for that clarification. Does anyone have any questions for Stephen? So Stephen, if you want to put your email in the chat window, someone can get a hold of you later on if they think of a question. All right, thank you. I want to thank all the presenters for finishing up their presentations today. Great job. Thanks everyone for coming out and spending your Tuesday listening to the presentations and asking questions. I wish everyone an enjoyable rest of the week, and we will see you back here perhaps sometime soon. Have a good day.